This is a demonstration of reaction rates. I have three vessels here. They're called cuvettes. Each has a dye at a certain concentration. I'm going to add an oxidizer to vessels 2 and 3. The oxidizer, if it reacts with the dye, will turn it colorless. So I'm going to add my oxidizer now. That's 60 microliters. Mix contents. As you can see, the reaction is not very fast. The decolorization, if it is occurring, is too slow to notice. A catalyst can increase the rate of reaction, and I'm going to add a catalyst to this third cuvette here. So now we may be able to see a difference in the rate of reaction in the presence of the catalyst. So by measuring how much color remains at any given time, we can mathematically calculate the rate of this reaction. So I will demonstrate that with the use of a spectrophotometer shortly. So now it should be obvious that the reaction with the catalyst has proceeded at a much greater rate. The red dye is almost completely destroyed in the presence of the catalyst. In that same amount of time, the oxidizer with no catalyst has not made any noticeable change in the color. So here I'm going to run an experiment with a spectrophotometer. This is the spectrophotometer. It's going to shine light, colored light, through the sample. If the sample is dark, much of that light will be absorbed. As the sample becomes less colored, more light will get through. So I'm going to measure the absorbance of light on my computer screen here over time as the reaction proceeds. To start the reaction, I'll use my catalyst again. And then I'll pop it in the machine and start collecting data. Mix the contents. The machine makes a beep every 2 seconds. It's collecting a data point every 2 seconds. On my screen here is the actual data being collected. This is the absorbance of light. So this is when it's darkest. It's getting less dark as the dye is being oxidized. So here's the final results. You can see the slope changes with time as the rate changes. It starts out fast and gets slower and slower. And down around here, it's just about finished. It's almost completely clear. So that's how you collect data that can be used for kinetic analysis. Here you can see what the machine actually did was take a bunch of single data points, single measurements. What was the absorbance at this particular time, and then it draws a line connecting them, and that makes that smooth curve previously seen. Now about an hour has passed, and you can see that the oxidizer did react, but it just took much longer. It took about an hour, whereas this took about 2 minutes for the oxidizer with the catalyst to complete its reaction.